Okay, oxygen hemoglobin dissociation curve. Sigmoid. But very important topic. See, O2 Hp dissociation curve. I am making just small heading here. Now I will give you all the graphs here. Fine. As you know that it is S shape. Okay, so this H shape at normal pH, normal O2, normal CO2, normal temperature, everything here. pH is neutral, that is 7.4. Normally, fine. So now I can erase this all the points and now I can write only here N. So you consider this N as a normal. Fine. But remember, shifted on the right side, that is known as harmful condition.
Yes.
Which harmful condition? Which points you considered here? For example, here I can make it as a dot manner. Shifted towards right side. Here which adverse conditions are there? Okay, but kई condition આવશે અહીંયા આપણે normal pH, normal O2, normal CO. Yes, good. CO2 increases, CO2 is more, O2 is less, temperature increases. So this graph is at 37 degrees Celsius, or you say that 98.6 degree Fahrenheit. Clear? But here temperature is more, so according to the carbon dioxide concentration more, you think about that pH is low. The blood become acidic. And another point, DPG, one point is there, diphosphoglycerate. 2,3-DPG is more. Okay, 2,3-DPG, 2,3-diphosphoglycerate. It's a pollutant, or it's one type of the chemical which harm a human being. Clear? Sorry. H plus increases the pH decrease કરી દીધી. So you only think about that carbon dioxide is more, so carbonic acid formation more. So acidic situation is created. So we say that pH become low. Clear?
Yes.
હવે જો હવે ગ્રાફ ને જે એક્સપ્લેન કરું છું બીજી રીતે આમાં મલ્ટીપલ ગ્રાફ્સ ડ્રો કરું છું. This is normal healthy person's graph. Oxygen hemoglobin dissociation curve. Generally it is sigmoid in shape, S shape. Barabar? Now I can draw the another graph which is shifted towards the left side little bit, that is a pregnant lady. See, compared to the adult person, male or female, pregnant lady consists more amount of oxygen to provide more amount of oxygen to growing fetus. So O2 is more, CO2 is less compared to the adult woman. Okay? Then graph is shifted towards little bit left side, that is of fetus. Compared to the pregnant lady, in fetus, more oxygen is there. Because compared to the aerobic respiration, compared to the metabolic process occurs in the pregnant lady, fetus consists more amount of oxygen for growth and development. Clear? And then the graph is shifted most side left one, that is of llama. So all the graphs are here. Fine. આમાં બધું મિક્સ આવી ગયું છે, ધ્યાન રાખજો. Normally at 37 degree Celsius temperature S shape, તો અહીંયા fever આવી શકે. Fever 37 degree Celsius or 98.6 degree Fahrenheit. So in fever, the graph is shifted towards right side. Temperature related बात करो. At 7.4, હવે pH ની discuss કરીએ. At 7.4 this graph is applicable. Normal. Less than 7. Clear? And more than 7. Here, so temperature wise that, pH wise that. O2 CO2 concentration wise, you know. Clear? So the most pure blood, that is of llama, which is on the most left side. Okay, so all the graphs are here included and your pH, temperature, બધું mixed છે. બધું એક જ ગ્રાફમાં આપણે કવર કરવાની ટ્રાય કરી છે. Clear? એટલે બધા જ પોઈન્ટ્સ કન્સિડર રાખજો. But remember that mug-up test, if the graph is shifted towards right side, harmful effect is created. But you think about that only DPG. DPG તમારા માટે આજે નવું છે. Diphosphoglycerate. That is 2,3. Actually 2,3 DPG bind with the hemoglobin and reduce the capacity of the hemoglobin to bind with the oxygen. In polluted air, oxygen is less. And along with that, if the polluted air is present in our blood, so that pollutant bind with the hemoglobin and reduce its efficiency. Clear? Chalo, fine. And one more point here, if the graph is shifted towards right side, affinity of hemoglobin to bind with the oxygen reduces, and along with that dissociation of oxyhemoglobin. The oxyhemoglobin which is present in our blood, it is dissociated. So oxygen present in our blood, that is used, and new oxygen is not bind to the hemoglobin there. That's why oxygen is less, carbon dioxide is more. The above points simultaneously consider करજો. नाम खबर पड़ गए तो प्लीज पूछ सको जो any doubt if you have. The general question is asked like that. Oxygen hemoglobin dissociation curve, if it is shifted towards the right side, which of the following possibility is there? Right, so ever the main class vichar. Clear? So this one is new. I think pregnant lady fetus ને લાંબાની તમને NCERT માં ડિસ્કશન આઈ થિંક કરેલી છે મેં, પણ DPG નથી કીધું. તમે લો pH કહો કે હાઈ H+ કહો, લેસ HCO3 માઈનસ કહો, because pH is equal to minus log 10 based H+ concentration. Applying chemistry here, because you know that pH plus pOH is equal to 40. Right? So pH is less, so H+ is more because minus value there. Yeah? Okay, આ પોઈન્ટ તમારે આવશે. Okay, right, one point. If more CO2 concentration, if more CO2 concentration in blood leads to dissociation of hemoglobin, dissociation of oxyhemoglobin, leads to less affinity of hemoglobin to bind with oxygen. First, more CO2 concentration leads to more dissociation of oxyhemoglobin, leads to less affinity of hemoglobin to bind with oxygen. This is known as Bohr's effect. So please everybody underline, high concentration of CO2 in tissue. High concentration of CO2 in tissue, that is known as Bohr's effect. In tissue it is more. So tissue exchange the CO2 in between the blood and cell, fine. So at last what happened? CO2 is more. But if in blood as well as tissue, both the sides CO2 concentration is more, O2 is less. So for fulfill the need of the oxygen, oxyhemoglobin which is present inside our blood, that is also dissociated to supply the more amount of the oxygen to the cell or tissue or like that, and that is known as Bohr's effect. Bohr's effect માટે ખાલી એટલું યાદ રાખજો કે CO2 concentration is more. That's all. Fine. And now next is chloride shift. Chloride shift, it is also known as Hamburger effect. Hamburger, Bohr, બહુ જ બધી વખત પૂછાઈ ગયું છે. Okay, now see, I want to discuss something here. See, CO2 transport through blood. એમાં આપણે થોડી વાત કરી હતી કાર્બોનિક એસિડ. So carbonic acid is dissociated into water and CO2. Fine. So CO2 is removed. But this all the processes occur at alveoli. Fine. At alveoli or at pulmonary level. हाँ, आपने जो CO2 ट्रांसपोर्ट डिस्कशन કર્યું હતું previous lecture, એ બધું ક્યાં ડિસ્કશન કર્યું હતું? Between blood and tissue. How the oxygen is reached to the tissue and tissue release the carbon dioxide and how it is transported through blood. But when carbon dioxide containing blood and reach at the pulmonary level, at the alveoli level, what happens? Right? So if carbonic acid is present, it is dissociated into water and carbon dioxide. So that carbon dioxide concentration is more here in the blood. Barabar? Then sodium bicarbonate, NaHCO3, you will take 2 molecules of it and form sodium carbonate plus water plus CO2. So at pulmonary level, sodium bicarbonate is also dissociated. Similar to that, potassium bicarbonate, 2KHCO3, converted into potassium carbonate plus water plus CO2. Same thing here. Alveoli નો છે જ છે. Alveoli માં oxygen, carbon dioxide, nitrogen, hydrogen, all the gases are there in the mixture state. But alveoli is only L is equal to exchange the oxygen as well as CO2. The nitrogen, hydrogen gas we are inspired. The same amount of the air can be expelled out. There is no exchange of the hydrogen gas as well as nitrogen gas. Okay, so at alveoli, but here we are talking about in the blood, not in the alveoli. This thing we are talking about the process which occurs in the blood, but at alveoli level. Now listen, in alveoli, when O2 is more, CO2 is less. Condition is there. In alveoli, when CO2 is low, O2 is more. I am talking about at the end of inspiration. At that time, dissociation of all the components leads to carbon dioxide release. That is known as Halden's effect. Okay. Chloride shift તો થઈ ગયું CO2 ટ્રાન્સપોર્ટ માં. આ લાસ્ટ પ્રોસેસ આવી. And this process occurs how? Due to formation of deoxyhemoglobin. Due to formation of oxyhemoglobin in the blood. Words पकड़ो तो ज खबर पड़શે हाँ नहीं तो कहीं खबर नहीं पड़े. After inspiration, after phenomenon, after inspiration, in alveoli O2 is more, CO2 is less. Fine. O2 is now moved from the alveoli to blood. So in blood, oxyhemoglobin is generated. But compared to that, CO2 concentration is low in the alveoli. So dissociation of all the components leads to release of carbon dioxide from blood to the alveoli back. This phenomenon is known as Hydens effect. આખી પ્રોસિજર તો ગોટાળા વાળી છે. પછી કોઈને ખબર ન પડે તો પ્લીઝ ક્લિયર કરજો. What is Bohr's effect? टिश्यू के ब्लड में CO2 વધી જાય છે. એ ટાઈમે dissociation of oxyhemoglobin means promote the exchange of O2 in tissue, that is known as Bohr's effect. CO2 come back to the blood and the transport of CO2 through blood. So at that time chloride shifting, that is known as Hemoglobin effect. But at last this CO2 containing blood reach to the alveoli. So at alveoli level, the CO2 containing blood at the end of the inspiration, more O2 is there in the alveoli. As a result, here what happened? Oxygen is moved here. So oxyhemoglobin formation occurs. But compared to that, CO2 is less in the alveoli. Leads to dissociation of all the components. Leads to release of CO2 from blood to the alveoli. That is known as Hydens effect. એટલે પહેલા Bohr's effect થઈ, પછી Hamburger effect થઈ, પછી Hydens effect થઈ. In this way, gaseous exchange occurs. હવે વિચારવા જેવું છે કે Hydens effect થઈ ગઈ એટલે CO2 is now expelled in the alveoli and then alveoli expel the CO2 in the atmosphere back. Now O2 is more, so oxyhemoglobin is more, and now this oxyhemoglobin containing blood can reach to the tissue. It is dissociated. That is Bohr's effect. If you connect that all the points, continuously this process occurs, and in this way O2 and CO2 all are transported. આ બધી effects સમજવી બહુ જરૂરી છે. Very important for NEET exam. બાકી તમને હજી એક લેવલે ખાલી O2 CO2 ટ્રાન્સપોર્ટમાં થોડી ઘણી ખબર હશે તો ચાલશે, but these effects are very important. ચલો fine, anybody has any doubt? If you have, then ask me. If you are confused anywhere else. Sorry?
CO2 is blood. In alveoli, it is more in less.
In alveoli, O2 is more, CO2 is less. O2 blood માં આવી ગયો, but CO2 is more in blood. That is exchange. CO2 moves from the blood to the alveoli. So this is this one, CO2. At alveoli, but here is all the things in blood. But at alveoli level. પછી expiration થશે. Expiration જ્યારે start હશે ને ત્યારે oxyhemoglobin containing blood move towards the tissue. And after exhalation, inhalation occurs. At that time, new CO2 containing blood reached to the pulmonary level. Again, exchange occurs. But again, new CO2 is entered inside the blood, and old CO2 is given to the tissue already. હવે આ કઈ રીતે સમજાય ખબર છે? હું તમને મસ્ત એક ટ્રાય કરીને તમને એક્સપ્લેન કરું છું. સપોઝ તમે વિચારો કે આપણે સ્ટુડન્ટ્સની એક કોન્સ્ટન્ટ લાઈન બનાવી. આપણે આજે સપોઝ આ પાર્ટ છે એમાં એક સ્ટુડન્ટની લાઈન બનાવીએ, બરોબર? Here you consider the tissue. In between that heart is there. So CO2 containing blood. હવે તમે જો heart ને કનેક્ટ કરતા હોય તો CO2 containing blood entering the right auricle, then right ventricle, and then to the lungs. Then lungs provide the oxygen to the blood. So pure blood from pulmonary vein to the left auricle, left ventricle, and then aorta. હવે આપણે વચ્ચે હાર્ટ ને મૂકી દઈએ. At the end of the part tissue there. Sorry, tissue અહીંયા છે, lungs ત્યાં. Here tissue is there. Here heart is there, and at the end of the part lungs are there. બરાબર? Students ને constant move over. બહુ જ મસ્ત સમજવા જેવું છે. Students ने constant move on, कोई ऊभू नहीं रहवा. So on this side, the line of the student consists CO2. આપણે બધાને CO2 પકડાવી દીધી. ને આ સાઈડની જે સ્ટુડન્ટ્સની લાઈન છે બધાની પાસે O2 છે. સમજો. Simultaneous movement સમજવાની છે તો તમને ખબર પડશે. This is in the synchronized manner. When the student who is here give me the oxygen, at that time alveoli gives the oxygen to blood to that student. એક સ્ટુડન્ટ અહીંયા છે, બધા સ્ટુડન્ટ લાઈનમાં કનેક્ટેડ છે. આ સાઈડની લાઈન છે, પણ જે સ્ટુડન્ટ લંગ્સની સાથે કનેક્ટ કરશે એ CO2 આપી દેશે ને લંગ્સને, O2 લઈ લેશે. At that time the student who is here give me the oxygen and I will give the carbon dioxide back to it. So now that student move forward. So next student move there and this student move in this direction. સાયમલ્ટેનિયસ પ્રોસેસ છે, પણ આપણે પાર્ટની અંદર એક્સપ્લેન કર્યું છે. એટલે તમને એમ થાય કે સર લંગ્સમાંથી ઓક્સિજન બ્લડમાં એન્ટર થયો હોય એ તો ટીશ્યુ સુધી એને પહોંચતા તો વાર લાગતી હશે ને? નહીં. અને એટલા જ માટે થઈને સાંભળજો, એટલા જ માટે when you close your mouth, close your nose, find at that time આપણને few minutes માટે suffocation નહીં થાય. Suffocation after few minutes start થશે. કઈ રીતે? So hemoglobin is there in our blood, is gradually dissociated, and that oxygen is given to the tissue, and tissue gives the carbon dioxide back to the blood, and when in the blood carbon dioxide concentration is more, then we feel suffocation and we are now stimulated for inspiration. ત્યારે આપણને એમ થશે કે હવે inspiration તો કરવું જ પડશે. That's why we are telling that if concentration of the CO2 is more in blood, then inspiration is stimulated like that. That efficiency is depend from person to person. ઘણા બધા person 1 or 2 minutes માટે suffocation feel પણ કરી શકે. But after feeling the suffocation, you will forcefully inspire to fulfill all the oxygen which is used at the time of closed our respiratory system temporarily. એટલે આખી સાઇમલ્ટેનિયસ પ્રોસિજર છે. ન્યુ સ્ટુડન્ટ્સ કન્ટિન્યુ મૂવ થાય અને આ એક્સચેન્જ થઈ જ જાય. CO2 is given to the alveoli or O2 comes in blood. At that time this will happen. As a result, CO2 concentration, O2 concentration, both are maintained in tissue, in blood, in alveoli, in this. But maintenance part. Everything is there in the maintained state. The amount of the air inspired by us, similar to that amount of the CO2 containing air, is exchanged at the time simultaneously. The oxygen which is present inside our blood, the same amount of the O2 which is taken in the blood, the same amount of the O2 given to the tissue. The same amount of the carbon dioxide is also taken, which is expelled from the blood in the alveoli. That's why concentration of the O2 and CO2 is maintained. I can use that word homeostasis. The steady state of the body is maintained like this. But a આખી synchronized manner છે. એ ઘણા મને ક્વેશ્ચન પૂછ્યા હતા કે સર લંગ્સ માંથી O2 બ્લડ માં આવી જાય પછી એ ટિશ્યુ સુધી પહોંચતા એને વાર તો લાગે ને? નહીં. Already inspiration through આપણે જે O2 is there in our blood, that is exchange. અને કે સેલ દૂર છે, blood lungs પાસે છે. So now the oxygen containing blood reach to the heart, then heart pump the blood outside of it, push into the artery, and then artery carry the blood. But હજી શોર્ટમાં જો ડીપમાં એક સ્ટેપ સમજવું હોય તો હજી આપણે લાસ્ટ સ્ટેપમાં જઈએ. You know, the whole blood of our body move within a 1 minute through our heart. So think about that. In 1 minute, the amount of the O2 can be taken inside our blood. The same amount of the O2 can reach to the tissue. Exchange of gases is very slow. That's why respiratory rate is slow than the heart rate. Heart blood ने फटाफट push करी दे. The blood reach to the cell rapid, but exchange of gases, concentration changing to maintain the homeostasis. Everything is maintained in the steady state. That's why respiratory rate is slow. Because exchange of gases occur gradually, the blood moves to the alveoli level. Gradually it becomes pure and CO2 is expelled in the alveoli. That is very slow process. But compared to that, oxygen containing blood, same amount. Same thing occurs at the tissue level also. Tissue level માં પણ tissue માં concentration less થવું જોઈએ ને? In tissue, CO2 is more, O2 is less. Then and then dissociation of hemoglobin occurs. And then O2 CO2 exchange occurs. હવે રેસ્પિરેશન કરીએ. આવું થાય સમજાશે. આના કરતા તો એમ થાય કે કઈ નહીં સર વધારે કહેવાય હાઈ CO2 એને વધારે જોતો હશે તો લઈ લેશે, ન લે તો લાગે. આપણું રેસ્પિરેશન ચોક્કસ બધું છે. આમાં કેવું છે કે in CSF and in blood CO2 is more, then brain gives the message for inspiration. હવે તમે રનિંગ કરતા હો બહુ મસ્ત જો પ્રેક્ટિકલી સમજવાનું જો તમે ડાયજેસ્ટ કરી શકો તો સમજવાની ટ્રાય આપણે રનિંગ કરીએ દોડીએ એટ ધેટ ટાઈમ આપણે બહુ ઇઝીલી કહીએ કે રેસ્પિરેટરી રેટ ઇઝ મોર, હાર્ટ રેટ ઇઝ મોર, બ્લડ પ્રેશર ઇઝ મોર. એ ટાઈમે ગેસિયસ એક્સચેન્જ લેસ થશે, એ બ્લડ ફટાફટ મૂવ થશે. એટ ધેટ ટાઈમ આપણે શેલો બ્રીથિંગ કરીએ. For doing the muscular work, we are doing shallow breathing, short breathing, because we need more oxygen supply to the muscles. We are doing more muscular work. And when you are tired, at that time you inspire deep. Suppose આપણે દોડીને થાકી ગયા, મજા આવે એવી વસ્તુ છે જો બધી ખબર પડે ને તો આપણે દોડતા હતા ને ત્યારે આપણે શેલો બ્રીથિંગ કર્યું, બહુ ફાસ્ટ બ્રીથિંગ કર્યું, બીકોઝ આપણે રનિંગ કર્યું, ટાયર્ડ થઈ, મસલ્સ આર ટાયર્ડ, વી આર ટાયર્ડ. એટ ધેટ ટાઈમ વી ટેક રેસ્ટ. એ ટાઈમે આપણને બોલવાનું હોય તે આપણને વેત નહીં રહે. પ્લીઝ લીવ ફોર ફ્યુ મિનિટ્સ. At that time we respire deeply. આપણે deep breathing કરીશું to supply the more oxygen which is used rapidly in our blood. Then when it will be normal, તો પાછું tiredness થઈ જાય પછી આપણો breathing rate little bit slow થઈ જાય, then it's normal level. And after few minutes when we are normal, then again respiratory rate becomes normal. Is equal to respiratory process. How બધું છે આમાં? ના આટલું જ છે પણ છે ઘણું બધું. આપણને ઈઝી લાગે કે lungs provide oxygen to the blood and blood provide oxygen to the tissue, but it is very complex process. CO2 ટ્રાન્સપોર્ટ માં તો ઘણા બધા સ્ટુડન્ટ્સ ને 2-3 વખત રિવિઝન કરાવ્યું. આ જ્યારે ઓલું ઓલ્ડ સિલેબસ માં હતું ને ત્યારની વાત ત્યારે આપણે બધું એ ઇફેક્ટ આપેલી સિલેબસ. એનસીઆરટી માં તો બહુ બ્રીફ માં આપેલી. Chalo, fine. Here, everybody. Sure. Okay. So remember, Boas effect, Hamburger effect, and Highlands effect. Fine. Okay, now check in the textbook. Every 100 ml deoxygenated blood delivers around 4 ml CO2 to the alveoli. Isn't that? So please underline that. Every 100 ml of deoxygenated blood delivers around 4 ml CO2 to alveoli. So that's all about the CO2 transport, gases exchange, and all the effects. Okay, now Here we have three respiratory centers. One is ERG, dorsal respiratory group, and another is VRG, ventral respiratory group. So another way we say that dorsal respiratory center and ventral respiratory center, both the centers are present in medulla. And third center, that is pneumotaxic center, which is present in pons. Pneumotaxic center, which is present in pons. Okay, right, the next point. Dorsal respiratory center is normally working. Dorsal respiratory center normally working during normal respiration. Dorsal respiratory center is normally working during normal respiration or breathing, which stimulates diaphragm and EICM normally during inspiration. Understand? So during normal breathing, dorsal respiratory center is working fine, and it stimulates the diaphragm and external intercostal muscles (EICM) during inspiration, because you know that during inspiration the diaphragm and external intercostal muscles both are contracting. Clear? Okay, here I can stop now. Fine. Remaining thing we will discuss in the next.